Michelle, Ingrid, and Sammy. Today we're going to be showing you how to do the tablecloth trick. All right, Michelle?
So what you will need for this experiment, you need a tablecloth with no hems and a smooth surface such as a table, a desk, or anything you have.
All right, you will also need a heavy object, or in our case, a table setting. You should all know how to set up a table setting by now, but just in case. Forks go on the left, knives and spoons go on the right. Your dessert spoon up top. You go your plate, your salad plate, your soup bowl, not just your soup bowl. You do a bread plate and your butter knife, and then right here should be your glass of water. However, it's currently holding up our phone, so here we go.
So the first step is to lay a tablecloth on a table with a smooth surface. We want the tablecloth to be slippery so the force of friction is small and the cloth slides out from underneath the objects without dragging them too much.
Then of course you want to construct your table setting.
As described earlier. So we'll be pulling the tablecloth at different speeds. We'll have a really fast one and a really slow one. When you pull it really fast, you want to flick your wrist. So it goes fast, you want to pull up and toward you versus down. Okay, so when you pull it slowly, you observe that the table setting moves with the tablecloth versus, as you'll see later in the videos, when you pull it fast, then it doesn't.
Yeah, so when you pull it really, really fast, you'll notice that the heavy objects, in this case the table settings, remain on the bare table. Mostly where they are, they don't move towards you. They will move a little bit purely because of friction. However, we notice that mostly they stay where they are.
Walking all the way over. I'm already late every day.
Oh no. Oh no. Let's go. Actually up. Okay. Ready, set, pull. Better. Nothing went off the table.
Nothing got pierced.
Go. Faster. Remember, fast. Fast. Think fast. Oh. Yeah. Okay, ready? Wait, guys. You two have to pull really fast.
Okay, ready, set,
go.
I've been on your bar. So, why don't the objects slide off the table with the tablecloth? Plain and simple, the tablecloth trick works because of inertia. In Newton's first law of motion, he describes inertia as the tendency of an object to remain at rest until a net external force acts upon the object to move it by speeding it up, slowing it down, changing its direction, or stopping it.
The inertia of the objects on the table keep them where they are despite the rapid sliding of the tablecloth underneath. Inertial mass, M, is the measure of an object's reluctance to accelerate, usually measured in kilograms. Inertia is the property of a body proportional to its mass in that it continues in a state of rest or uniform motion in the absence of an external net force. The greater the mass, the greater the inertia of the body.
This experiment also demonstrates impulse momentum. In this case, both the horizontal force and the time during which they act are small, which results in a small change in momentum of the dishes. There is another component to consider: friction. The horizontal friction force on the tableware is due to kinetic friction between the dishes and the tablecloth as we pull the tablecloth horizontally. If we pull the tablecloth very quickly, friction between the dishes and the table surface rapidly removes any horizontal velocity of the dishes, thus keeping them at rest. So thank you everyone for tuning in to Physics Pals.
We hope to see you soon.
Yeah, we hope to see you soon. Hope you enjoyed our tablecloth trick. And thank you.
Bye. Bye. Miss Dieter, do you know why this happens?
Inertia.
Yes.
Quick, go. You are speed. Oh. Remember, just fast.
I also want to try, but I don't want to.
Yes.
Okay, ready?
Go slow. Go fast.
Yes.
Fast, like lightning. Like so fast. So fast, Jack.
Yes.
We've done like a lot of
Hey, Adam, do you know why the plate doesn't slide off the
I
table?
think it's Newton's 69th law.